Okay, let's try problem 3.28. A ball with a horizontal speed of 1.25 meters per second rolls off a bench 1 meter above the floor. How long will it take the ball to hit the floor? And how far from a point on the floor directly below the edge of the bench will the ball land? Okay, so the first thing to do here is just draw a simple picture. Just draw a bench with a ball on it. We know this is 1 meter from the floor to the end of the bench, 1 meter. And we know that's given an initial velocity of 1.25 meters per second. And we're asked how long will it take the ball to hit the floor. So now we have two different components here. We have the x component, which has an initial velocity of 1.25 meters per second, and we have the y component, which is just essentially free fall. So let's go ahead to figure out how long will it take the ball to hit the floor. And let's use our equation that relates distance and acceleration. So we know y final. So the final position is equal to the initial position, y initial, plus the initial velocity in the y direction times time plus 1/2 times the acceleration times time squared. And so we know that since it's just free fall, right, our initial velocity is going to be 0. So this term is going to go away. And we know the acceleration. The acceleration is just going to be equal to gravity. But it's negative, right, because gravity is going to be pulling that way. And so let's just rewrite our equation real quick. So this just becomes the final position, which is going to be 0, right, because it's going to the floor, is going to be equal to the initial position, which is 1, because it starts from up here. And we said this is 0. And then filling in negative g for the second part becomes minus 1/2 gt squared. Okay, so now we know everything. We know y final, we know y initial, and we know the value for g. So we can just rearrange this equation and solve for t. So let's go ahead and do that. So subtracting the y initial from both sides, we get y final. Y final minus y initial is equal to, this is y, negative 1/2 gt squared. So now I'm just going to multiply negative 2 to both sides to get rid of the 1/2. So this becomes negative 2 times y final. I could do that. Y final minus y initial is equal to gt squared. And now all I have to do is divide through by g, and we'll get our solution. So this just becomes negative 2 times y final minus y initial is equal to t squared. This is over g. Okay, so now just take square root of both sides, and we have our final solution. So now all we have to do is fill in these values. So we know that the final position is 0, so negative 2 times 0 minus the initial position, which is 1, over g, which is negative 9.8. Oh, we already counted for the negative up here when we put in g. So 9.8 meters per second squared. And this is the square root of this. And this is equal to the square root of 2 over 9.8 meters per second squared, which is equal to 0.4525 seconds. This should have a meter attached to it. Okay, so that's our solution for part A. So it's going to take the ball 0.4525 seconds to reach the ground. Okay, so now let's do part B. Part B is a little simpler. So we're actually going to use the same equation from part 1. However, if you notice, a lot of the stuff goes out. So we're just left with y final, right? Because we want to find the initial, the final position that goes to, and we know y initial is going to be 0, so this goes away. We have an initial velocity, so this part of the equation right here stays. So v I x, so initial velocity times time, and then there's no acceleration, so this term goes away. So all we're left is the final position is equal to the initial velocity times time. And so we know all that. So this is equal to the initial velocity, which is 1.25 meters per second, times time, which we calculated in the first part, so times 0.4525 seconds. And our seconds cancel out, and this is equal to 0.565 meters. So that's how far the ball reaches when it leaves the bench to right here. So this distance right here is going to be 0.565 meters. And that's problem 3.28.